All right, well, let's talk about SQL Server performance monitoring. My name is Chad Renstrom. Before we get too far into things, I do want to mention thanks to everybody who's putting the conference together, to Ben and William for giving me the opportunity to speak, and to Deepthi again for being my mentor. The presentation wouldn't be what it is without your help. So I'm Chad Renstrom, like I mentioned. I've been around SQL Server for 25 years now. And then the first 20 years of that was with, in smaller organizations, the whole multiple hats thing where I was either myself or a group of three of us were designing, implementing, building, supporting the entire infrastructure, including servers, network storage, backups, plus the applications that are connecting to SQL Server. So reporting services, analysis services, some integration services, Power BI recently, FRX way back in the day, plus other custom applications that are out there. I do have my contact info at the end also, if there's any follow-up questions for things. But why you might be here is if you're supporting a system that's running 24/7 and you're on call and getting questions about some timeouts. Or maybe you're getting ready to go home, but you're getting messages about a server that you've never even heard of. Maybe it's SQL Server. Maybe your ETLs are running longer than they usually do, or maybe you're trying to do some last-minute budget planning. I've used performance monitoring to help with all of these things, whether it's looking at what has happened in the past, what we might be able to change to resolve those in the future or detect them faster, or looking at things that are happening right now and maybe fixing it even before our end users reboot their workstations, or using those numbers from the past to build a picture or forecast what usage might look like going forward. So what we'll talk about is tools that are available for monitoring, the resources and how SQL Server uses those, because it's hard to monitor something and know if it's good or bad if you don't know how it's used, how we could identify if a SQL Server is being slow, and then how a query could be slow. And we can't go into super deep on any of these because there's multiple hours worth of sessions and training on each of these topics, but hopefully it'll be a good overview to at least help you get started on something. So tools that are available. Microsoft has several tools available on Windows Server and SQL Server. Performance monitor counters have been around for years and years now. There's dynamic management views within SQL Server that pull lots of data out of SQL Server metrics to show us what's happening. There's also extended events in SQL Server if we want to get more in depth on something specific that's happening, or Query Store if we have that enabled on our databases to get more information about how our queries are performing over time. There are a lot of other resources that Microsoft provides out of the box, essentially, at this link here. Way too many to list on the screen. A lot of them are more specific scenarios. So if there's something detailed that you're looking for, take a look at the list, and there might be something there that can help. Beyond the out-of-the-box stuff, there's things that we can add on, whether it's community source scripts that people have written and provided to the rest of the world for using. Many of them are good. Several of them are good, I suppose. There's also monitoring platforms out there. So that's where we can have a system or systems dedicated specifically to monitoring, whether it's open source or commercial. This graph down here is one that I made using Grafana, but yours might not necessarily look exactly like this, but you're still going to have CPU usage of some sort because everything's using those same sources of data, whether they're using the performance counters or DMVs or the extended events or Query Store, they're still using those sources to build the graphs that we have. So why you might use a monitoring platform, or this is sort of the quick version of why I recommend doing a platform, is they're more accessible to non-SQL experts. So if you're presenting to leadership, they don't have to know the details of what this particular number is, what blocking is, but you can at least point out on the graph what's good and what's bad. It also helps us as administrators accelerate our problem identification. We can find out what's happening faster. If you're like me and you're responsible for multiple systems, you can get all of that information into one screen, and it makes it easier to identify things that you might not necessarily be seeking out, or somebody might not be telling you, but you can go find that problem faster. Those systems also have automated responses and alerting possibilities. So you could get emailed or some sort of other notification or some sort of automatic way to respond to the system, or aggregations. And this is a big one for me because the raw numbers out of some of the metrics aren't necessarily as user-friendly. So being able to do some aggregations is very helpful. But let's talk about the resources. We connect to our systems over the network. We're generally not on the same server as our SQL server is to run applications. Data is on a disk somewhere. SQL Server can't connect or doesn't use that data directly off the disk, so it has to load it into memory first. Then once it's loaded into memory, then the processors can do the operations or the queries that we're asking it to do. Let's dig into this a little bit more. So the processors, those are assigned when our servers are built. Generally 4 is a minimum, can be less, can scale quite a bit higher. We can think about cores as defining the number of things that can happen at the same time on our servers. For SQL Server, everything uses CPU. So if our CPUs are busy, that means our queries or whatever we're asking it to do has to wait until there's time available. So how can we monitor this? So one of the basic ones that's been out there for a long time, and our server admins use these numbers as well. This is a perf counter. This is looking at the total number of CPU usage here. For SQL Server, though, I like to look at the individual cores as well. And I'm looking for outliers to see if there's a processor sitting at, or one core sitting at 100%, or maybe down at 0%, and that could actually indicate a licensing issue if your licensing is limited on how many CPUs you can have. I'd like to look at the individual processes itself. I like to compare SQL Server, and no, that's not misspelled, to all of the other processes running on the system. So if we're seeing high CPU on a system, we can look at the processes to see if it's actually SQL Server or not. Because if it's not SQL Server, we don't need to dig any further into that. We need to find out what else is running on our system using up our valuable CPU. If you're using Enterprise Edition, I want to point out that if you have Resource Governor configured with workload groups, you can get more detailed CPU metrics if you through those workload groups. Again, that's only in Enterprise Edition. If you have questions about how that works, feel free to reach out and we can dig into that together later. So memory, and this is where I get the most questions from sysadmins, folks that are server admins. Often the question is something like, the server is not busy, but this memory usage is sky high. It's 85, 90, 95, or even almost 100% use. Is there a memory leak of some sort? What's going on? SQL admins generally know that SQL Server uses a lot of memory. And the reason is it uses, when it runs a query, it loads that data off of disk into memory, but it doesn't unload it when the query's done. It keeps it in memory just in case it needs it again, because memory's faster than disk. But what happens that when it reaches a maximum of some sort, SQL Server will start unloading that older memory from disk, or not from disk. It'll start unloading that memory, the data from the memory, to make room for new queries. The other thing that can happen is the operating system can take data from memory and put it into what's called a page file or swap file, depending on what operating system you're familiar with. And that's actually on disk. So what's happening if that's SQL data, we're reading it off of disk into memory, the operating system is throwing it back onto disk, and now when SQL Server wants that, the operating system says, hold on a second, I need to go get it. It loads it back into memory off the disk again, so now SQL Server is hitting disk multiple times, even though it might look like a memory issue. So the goal here is to not let SQL Server use that page file or swap file, whatever you want to call it. One setting we can use is the max memory setting, and that sets that limit for how much SQL Server can use of memory. We want to make sure that there's enough overhead for all those other things like the operating system, whatever else might be on the system. Those numbers can vary, 70%, 80%. It kind of depends on how your system runs. Lock pages in memory is another setting that we can use. And what that does is that tells the operating system that no matter how much memory pressure you're experiencing, you can't put this onto that page file. That can be a problem if you don't have enough overhead for those other things, because it could lead to overall system instability, and that's not good for anything on the server. I also want to point out this trace flag 8121. This was brought to our attention by a vendor because it creates some more restraints around how SQL Server uses memory when it gets close to that max memory setting. So how do we monitor our memory usage? Again, this is another familiar metric. This is a DMV, though it can be a performance counter as well. This is when a SQL Server rebooted. So it started at 148 gigs, slowly works its way down, and then it just sort of plateaus here at around 23 gigs of actual memory use. Within SQL Server, we can see what's happening by looking at the target and total server memory. Target server memory is that it matches our maximum, so how much SQL will load off of disk into memory, into the buffer pool. Total server memory here, it's not just the buffer pool, but that's the main thing. Total server memory is how much it has loaded. So it starts down here, gradually goes up, and then it plateaus. Like we mentioned, it's just sort of a reverse of the last screenshot that we had. But it's steady right around that target. So memory grants outstanding and pending. This is another one that I like to look at. And this isn't the amount of memory that's being used, but how many things are using memory. Both of these particularly are DMVs, but they're also performance counters. So the memory grants outstanding is how many things are actively using memory. So the last time that this graph refreshed, there were 12 things actively using memory, and there were 4 in the memory grants pending. So that's the number of things that are essentially waiting in line or would run once memory is actually made available. So this graph could indicate that there's some memory pressure going on. If it's a concern of ours, then we can dig into this. So disk. And remember, disk is slower than memory, and we have to get the data off of the disk into the memory before SQL Server can do anything with it. But disk is also where, or storage is where our data lives when our server reboots, so it still exists when the server comes back up. So it's important, obviously, but it's also slower than what it would be if it were in memory. So from a DBA perspective, one of the things that we can focus on is our disk I/O, keeping that as low as possible, prevent have as few interruptions to that I/O, or the reading and writing, as we can. One of the things that we can set is the auto-grow all files setting. And what that will do is when our database files reach a specific, or when they fill up, it will automatically add more space to our files. Could be good or bad. We'll talk about that in just a moment here. Instant file initialization is auto-grow all files. Let me back up for a second. Auto-grow all files is if you have a database where you have multiple data files within a file group, the idea is SQL Server will use those use those connections to distribute its load. So it doesn't overload one specific connection, it has multiple connections to use, so not one thing gets overloaded. That's what the auto-grow all files does. So all the files will be increased anytime one file needs to grow. They all are increased in space. Sorry about that. Instant file initialization is where SQL Server will add, when it does grow those files, it can be a very slow process. The instant file initialization speeds that up. This does apply to log files in 2022, as long as that growth is 64 megabytes or less. So instant file initialization. the thing to remember about this, how this works, how it makes it faster, is disk storage is reusable. So SQL Server files, when a file is added or grows into new space, it's probably not the first thing that was on the disk in that physical location. The reason for that is when a file is deleted, the information about the file is deleted, but the actual data itself still lives on the disk until something overwrites it, such as SQL Server. So if instant file initialization isn't enabled, SQL Server actually goes through and it writes zeros to all of that new space on the drive. With instant file with the IFI or instant file initialization enabled, it skips that whole process. There is a small security risk there, depending on what files were on that drive ahead of time. So it's possible to read that data, even though it's technically deleted. It is recommended by Microsoft. They do explain more details on how the security works. You could also check with your storage people to find out if your storage platform does any zeroing automatically. So how can we monitor our disk latency? There's a performance monitor counter for that. Physical disk, these numbers here for read and write, the 50 milliseconds and 5 milliseconds, that's from one of our primary vendors. Your numbers may vary. I've seen this lower, sometimes even 40 milliseconds, 35 milliseconds is a recommendation. But the main thing that we're looking for here is we're not looking at these spikes. We're looking for more overall trends to see if there could be a problem. And we're looking at read latency on this particular graph. So if I were curious if there was some sort of a disk issue, I might look at this 10 o'clock to 10:10 time frame and zoom in on that to see if there's more of an overall trend or if these are just individual spikes. And then if it does look more like a trend, then I could go talk to my storage folks to find out what's actually happening. File size, and this relates back to our file growth. So when our database files reach, when they reach their capacity, essentially, then it needs to add more space. During that time, SQL Server pauses all of the operations, so all of our queries and things have to wait until that file is made available. So this DMV here, we can see that file size, which is being graphed over here. But we can also see how much is used and how much is free. So we can see, we could use those numbers to then project out when we might need to grow our files in order to, we could then plan it so it happens when it's convenient for us and it has less impact on our applications or end users. Any questions so far? Otherwise, I'm going to jump into a demo. All right. We'll come back to Management Studio here in a second. So what some of these counters look like. And this one here in the top left is looking at the processors, the perfmon counters here. I can also enable the individual cores on my laptop here. There's not a whole lot going on. If this were an actual SQL Server, we'd probably expect these to be up a little bit higher. But the main thing that we're looking for is that everything is kind of together. There's nothing sitting at 0%, nothing at 100%. Everything's kind of together for the individual processors and the individual cores. We can also see our SQL Server compared to everything else. So SQL Server is down here across the bottom, but our idle and total are both up here over 100%. And I want to point that out because we'd have to do some math in order to know what everything else is doing. We'd have to take the total, subtract the idle and SQL Server to see what everything else is doing on the system other than, and then we can compare it to SQL Server to see what's happening. Again, my laptop, I'm the only one on here, so there's very, very little activity. For our purposes, right now, we'll just keep looking, we'll just have that total usage running. Over here on the right is our memory. So right now on my laptop, I have almost over 7.5 gigs available of memory. Memory grants outstanding. That's in SQL Server how many things are actively using memory. That number is at 0. The memory grants pending. The number of things waiting in line for memory is also at 0. Again, my computer isn't doing anything right now. Target server memory is at 2 gigs. That's how much SQL Server will load from disk into memory. That's how large it can grow that, how much memory it can use there. And this total server memory, that's how much it's using. It's just under 500 megs. So this could grow up to this target amount. So down here is our disk latency. Again, I only have one drive local on my computer here. And I have this scaled up so we can see something, and I have it showing both read and write together, just so we can see some sort of numbers, and got a whole 1 millisecond of maximum latency while we've been graphing here. But let's make these do something. So I'm using the AdventureWorks 2019 database. The only thing that I've done or modified in there is I've made a couple of copies of this table. One of them, the only thing that I changed on it is the statistics. So SQL Server thinks that there's 50 million rows, and another copy where SQL Server thinks there's only 5 rows. That's the only thing that I've changed in here if you want to recreate this yourself. Take a look at these, some performance monitoring metrics that we can see within SQL Server itself. The top one here, this shows how much memory we have. Again, this is very similar to that performance counter we were looking at, where we're looking at DMVs in SQL Server. So we're over 7.5 gigs available. The maximum memory. So this is the setting in SQL Server where you can tell it how much memory can be used, and it can't go above that amount, or it's not supposed to go above that amount. Lock pages and memory is another setting. I generally wouldn't enable this setting on a system this low. I wouldn't really think about enabling it until a server gets up to 64 gigs or beyond that. But I have it enabled here just for demo purposes so you can see where that shows up. And then we have our target and total server memory. So 2048 are 2 gigs. For our target, that matches our max server memory setting. So SQL Server is recognizing that. Total server memory, so this is, again, how much it's actually using. So 485 megs of the 248, or 2048. Memory grants outstanding is at 0. Memory grants pending is at 0. We saw that in the performance counters also, that there's nothing actively using memory and nothing or no queries waiting for memory either. And there's a couple disk ones here also. So our disk latency, these are a little bit different than what we could see in the performance counters. This is looking at the database file itself. So we can see on this file, we've had 64 milliseconds of stall over 119 operations since this SQL instance was started. So these are accumulating numbers. So we'd have to do some math to figure out how it's changing over time. Down here, this is looking at our file size. We can see that our file is at 328 megs. We can see how much is used within that file, 312, and 15 megs free. All right, so let's change the numbers a little bit here. So I'm going to grab a copy of this query, and this is going to be querying from the table that has 50 million rows, or where SQL Server thinks it has 50 million rows, though it only has about 20,000. I'm not going to run it quite yet because I want to get all of these performance numbers here showing up. We'll get a copy of it. And on this side of the screen, I'm going to expand it a little bit. This side of the screen will have our before numbers. And if my mouse cooperates, we'll run it again over here. This will end up being our after numbers so we can compare them. Let's start our query, and this is going to run 20 times. Let's go look at our performance counters while that's happening. We can see that our processor is increased a little bit, not a lot, but there's some activity. If we can look at the SQL Server process, we can see that it is busy doing something. I mean, we know what it is. See that the available memory in my laptop is down. Actually, it's down around that 7 gigs. Decreased a little bit. Memory grants outstanding is now at 1. So there is that one query running that that we started. Memory grants pending is 0. So there's none waiting in line for memory. Target server memory is still at 2 gigs. Total server memory has increased up to over 600 megs. Now the memory grants outstanding dropped down to 0 here. So we can assume then that our query finished running. But before we go check, we'll look at our disk latency numbers. Still very, very good. Even during that time, we've had a whole 1 millisecond of latency, so no disk concerns at all. So let's look at let's get our after numbers here. We'll get our before numbers on the left. We have a timestamp so we can see which one ran first, of course. Then we have our available memory on my laptop. We can see that it did decrease 300 megs or so in that time. Our max memory setting hasn't changed, and our locked pages of memory is still enabled also. We didn't change those, so that makes sense. Target server memory is still at that 2048, matching our max server memory. Now this number can decrease if SQL Server recognizes that the overall system is running into some memory contention issues. It can decrease this target server memory on its own to limit itself to ensure the overall system stability. Total server memory, we can see that it did increase from 485 to 648. So 200-ish, 150 or so megs of memory increased. Now our query did finish running, but it didn't unload that data from memory. So it's still there. If we were to run the query again, it would theoretically be faster. Memory grants outstanding is 0 and memory grants pending is 0. That matches the performance monitor counters that we saw where it was at 1 and dropped back down to 0 when our query finished. So our disk latency, looking at the individual database files, we're now at 386 milliseconds of stall over 395 operations. Could do some quick math here. Again, these numbers are from the time that our server instance restarted. But doing some math, we can see that there's less than 1 millisecond per operation. Then we could use our timestamp, actually. If we wanted to do some math, we could subtract out these numbers from these numbers and then figure out how our milliseconds per operation per second, or however much time you want to delimit by. But again, under 1 millisecond since it started, so probably not a concern. And our database file sizes, those haven't changed either. We're still at 328, 320, or 312 used. Again, if these numbers were changing because we're actually writing to the database, then we could do some projections on when we might expect that file growth to happen either automatically or we can control it ourselves too and schedule it. All right, one more thing I want to show you in here. Scrolling down to the bottom, I've got essentially the same query. The only difference is it is pulling from the table where it thinks it only has 5 rows. I'm actually going to change the alias in here so I know that it is pulling brand new stuff, so it's not using any feedback or anything like that. Trying to make it go faster on its own. We want to see how terrible it can be. We'll close the after numbers over here. We can always rerun it if we need to. I forgot to run this. We need to turn on the actual execution plan. So this will show us more details. It'll show us the actual things that SQL Server is doing. So if you've never seen one of these before, these are the operations that SQL Server is running to do our query. We read them from right to left. We can see that there's a table scan that happens, index, seek, a sort, our join. There's also some time numbers in here that are accumulative in this instance. If I reselect the operation on the left, we can get some more information if we look at the properties. We can see our memory grant was at 1 meg. If those of you are noticing some things, yes, we'll come back to those. So our memory grant was at 1 meg, and it used 1 meg. So it used all of the memory grant, or all of the memory that was allocated to the query. We can also see some query time stats. So we can see there was 789 milliseconds of CPU time used to run the query. So the query actually took about 1.5 seconds to actually complete. Something else that we can see in here is our wait stats. So 712 milliseconds of async network I/O. And then there's more on I/O completion and some memory allocation, blah, blah, blah. But what is that? Let's go back to PowerPoint. We'll look at that some more. So waits are what I like to think as excuses for why SQL Server isn't running a query. There's always waits of some kind, whether it's loading data from disk into memory, that registers as a wait. It's everything that it's doing, if it's not running a query, is logged that way. The thing to watch for isn't necessarily that waits are happening, but how long they're taking, or even if they're important. How do we know if they're important? Well, we can group waits into kind of these groups of queue waits. If it's not doing anything, that's registered as a wait. If it's waiting for something, if it needs access to something, or if it's waiting for data on a disk or loading to memory, or a memory grant even, or waiting for time on the CPU, or there's hundreds of waits. But there can be resource waits. We're probably a little bit more interested in those than queue waits. External waits are when our queries are waiting for something that's kind of beyond themselves. If it's a linked server query, it would be waiting for that data to come back from that other server before it could continue. It just doesn't have insight into what's actually happening over on that server. Or maybe it's running a DLL with the data to get stuff there. So these are all sorts of external wait kinds of things. So how can we see them? And we can look at the individual query when it runs to see how many waits there are, or what our wait stats are. There's also this DMV here, this OS wait stats, and these numbers are also cumulative. So when our server restarts, those numbers keep increasing over time. So then again, we would have to do some math to figure out how our rate of change is based on those numbers. So here, this graph is showing us these 3 waits and how that's changing over time. I think this graph is checking every 10 seconds or something like that. But those numbers are continuously increasing, so we just have to do some math to get those to show up. This is an example of where a monitoring platform is helpful, because a lot of that will just be built in. If you're specifically interested in CPU details and what's happening with waits, there is a column for signal wait time. And what that means is, so let's just say our server or a query needed to pull some data off a disk. It's ready to do that, but it has to wait for the CPU to be available because it uses a CPU to do everything. So it'll calculate, or it will accumulate, that's the word. It'll accumulate signal wait time while it's waiting for the processor to become available. So then it could actually load the data from disk. Again, that's if you're looking for more information on CPU. I've seen some ratios of 50%, but I think it really depends on your system and what wait stat you're specifically looking at. I generally don't use it a lot, but I know it's out there. So there are hundreds of waits. We're not even going to go through this list here. These are generally CPU related things, some memory things, disk I/O related things. And here's some external things. So there's that async network I/O. That was that top wait that we saw in the query. And that's actually an external wait because our query is essentially finished, but it's waiting for a client or management studio in our case to actually get those results and display it. There's also locks down here. There's a lot of different kinds of waits, but the main thing that I encourage you to do is take a look at your queries that you're specifically interested in to see what sort of wait stats they have, or look at your overall server wait stats to see what your system in general is experiencing. Then you can use a list that Paul Randall and others maintain out at SQLskills.com. It's one of my favorites. Microsoft also has documentation out on all the waits out on their website. So how else can we see them? So I like to use SP-Who is active. If you use SP-Who2 or SP-Who or the built-in performance analyzer thing, which has its own problems. One of the columns in SP-Who is active is wait info, and that'll show us the top wait for the specific session that we're interested in, or well, all of the sessions that are running at the time, and then we might be able to pick out one that we're interested in. SP-Who is active is available out on Adam McInerney's site. He's the one who built it. It also, there's a link there out to get the files from GitHub where it's maintained. If you want to collect this SP-Who is active information over time, these results can be logged to a table also. Other way that we can get information about our queries, other than SP-Who is active, because it's more than just waits in there, is Query Store. Nice thing about Query Store is our data is persisted through reboot. So even after it reboots, we can get information about query performance. Waits are one of the things that can be in here. This graph is showing our average CPU time over a specific, I think it was an hour that was selected. If we were seeing some CPU problems, this query here that is selected in green, that would be the query that we would want to dig into further. There'd be more information that shows up on the screen when you select it. There's also some DMVs or views that you can use to get more information from Query Store if the graphs aren't enough for you. If you don't have Query Store, here's where you find it. So if you want to enable it, you can do this through T-SQL as well. But in properties on your database, this operating mode, change that to read write. Query Store is off and running once you save it. There are settings here that you can evaluate to see, or if you need to, this will define how often it collects data, how often it's written to disk, that sort of stuff. Query Store has existed for several versions of SQL Server now. In 2022, any new databases have it automatically enabled. So once you have it running, then there are the default reports that show up underneath our database. So why else could queries be slow? What else can we look for? Excuse me. And these three aren't the only reasons why queries could be slow. These are probably the three that I see the most often, or the things that I go to first. So locking and blocking. Our queries, SQL Server ensures our data integrity. So our queries, if we're updating a phone number, SQL Server won't allow another query to go update that same phone number at the same time. The first one has to finish before the next one can go in and make edits or even read it in the default configuration. Now there's ways you can get around some of the blocking. Again, that's something we could talk about for hours after this session if you wanted to. I might leave the conversation, but there's a lot of conversation that could be had about it. There's also the main thing to watch for, though, on locking and blocking is long-term stuff. So if you're updating a phone number and that's taking several minutes, that's probably a problem. So how can we find it? So we can see there's a perf on counter looking at processes blocked. We can see how many blocking or things are being blocked over time. The last time this graph refreshed, there was 2. Again, if that was sort of steady, that might indicate a problem. So how do we know? How can we dig into it more for something that's running? Again, I like to use the SP-Who is active to pull that sort of information. Another one of the columns that's in there is blocking sessions. So for this particular session, we know that this one is doing the blocking. SP-Who is active has a parameter that you can add to it that will surface those lead blockers to the top of the list to make it easier and faster for finding out what's going on or what session is doing the blocking. If you want more details on blocking itself, there is the blocked process report within the extended events. There's a whole setup for that. There's a link here to go into that if you're looking for more details on blocking itself. I also want to mention deadlocks because this is when you don't know that it happens until afterwards. So say there's two queries running and they're trying to update something, but they're also trying to get a lock on what the other query has a lock on. So essentially they're at a deadlock, or they're at an impasse. Neither of them can finish without the other one moving out of the way. So what SQL Server does is it feels random that it picks the one who's done the least amount of work, and it actually kills that process. So then the application would have to resubmit that query in order to run, but it allows that other one to continue on with what it was doing. To get details on deadlocks, in the XML or in the system health session within extended events, the XML deadlock report event is collected. It's kind of a best effort thing, so it doesn't keep it for a long period of time. If you want to keep deadlock information for longer times, then you'd have to set up your own extended event session, and there's information on how that whole thing works, including how this one works. I personally like to use the SP Blitzlock from Eric Darling and Brent Ozar to dig into it. It gets the information out of this XML deadlock report so much faster than if I were trying to read through it myself. And then I can take that information, pass it on to the developers or application vendor and say, here's your problem. Go ahead and fix it for me. So another reason queries could be slow, and this gets back to the previous session a little bit. Something to remember about TempDB, though, is that there's one for every SQL instance. So it's a shared database across all of the databases that are there, all of the queries, everything's using that same TempDB. So contention's an issue. One of the things that we can watch for from an admin perspective is for disk latency and ensure we have enough space for TempDB. Some things to remember about TempDB is it's rebuilt, recreated every time the system restarts. If you have the option to use local SSDs, which is fairly popular with cloud services, go ahead and use it. You have to do a little bit of scripting in order to get the files and permissions there, but then the local SSDs are going to be faster I/O than what your SAN storage is. If it's rebuilt every time, doesn't really matter if it's persistent or not. TempDB is used for things like temp tables or anything else that's created in our queries. It's used for things like sort spills, joins, aggregates, and other things. And we do have time to show, and if you're reading ahead, you might know. But our sort here, so remember it was thinking that there were going to be 5 rows. So our memory grant was 1 meg, and it used that entire meg. If I highlight over this sort, where there's an exclamation point, there's a warning down here that says the operator used TempDB to spill data during the execution with spill level blah, 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 blah. It was granted 1 meg, and it used 1 meg of memory. So here's a great example where SQL Server allocated, it said, I think you're going to need 1 meg of memory in order to run your query. So it gave it 1 meg of memory. Our queries won't go get more memory if it doesn't have enough. It just runs with what it has, and it uses TempDB to overcome that shortcoming. So we could run the other query where SQL Server thinks there's 50 million rows instead of the 5. I still have the actual execution plan enabled here. So we can see it here. Plan looks a little bit different. There's not a lot of things going on, but we still have our table scan, index scan. We have a join happening, and here's our sort, and yeah, then some parallel stuff. If I reselect the operation on the left, wish I didn't have to do that to get properties to show up, but we do. But we can see that it was expecting 50 million rows for these things. We can see our memory grant was at 146 megs, so SQL Server said, I think you're going to need 146 megs in order to run this query. It actually used about 100. So it's arguably better, I guess. But if we extrapolate this out to gigabytes, you probably don't want 40 gigs of memory sitting there doing nothing. So the query itself could use some tuning in order to fix things. Obviously, in this case, it's statistics related. Actually, in most cases for TempDB spills, it's statistics related. But that gets into whole performance tuning stuff, which there's days worth of training on how on tuning queries. So how do we monitor TempDB? Excuse me. There's disk latency, which we talked about already, how we can monitor our disk usage, especially if TempDB is on its own drive. We can see how our I/O looks. We can keep track of our free space. So if we can then set our TempDB at or what its normal run size is, or you can fill up the drive if you want to, I suppose. But then TempDB doesn't have to grow while it's trying to be used. Something else that I like to enable is a SQL agent alert number 17. And what that does, and this is beyond just SQL Server, this will send a message out via SQL agent when SQL Server doesn't have enough space to grow TempDB, or if there isn't enough memory for a memory grant, or those sorts of things. It'll send out an alert when there aren't enough resources for something. To look at things happening right now, again, I like to use the SB who is active. There's a TempDB current column here that shows you how many 8K pages are being used. So you can see your largest TempDB users. If you want to do math to figure out how many megabytes or gigabytes that is, you can do that math. Somewhere else that TempDB can show up, and I had to doctor this image to get to just show that a TempDB error can show up, or not error, but a TempDB wait can show up here as well. Query Store also has a report on TempDB usage. So that's another way that we can see how much TempDB our queries are using over time. So your homework then with SQL Server Performance is to see what you have for monitoring tools. Open them up, get familiar with them. If you don't have a monitoring tool, talk to your infrastructure folks. Find out if there is a SQL Server add-on where you can start collecting the SQL Server detailed information. See what your CPU, memory, disk, see how those things are being used in your system. Kind of establish that baseline, if you will. Take a look at network, or you can take a look at network. Though in today's world of virtualization, any network bottleneck is likely going to be upstream from your SQL Server. Probably not going to find a network problem on your server. TempDB, see how large it is. See if you have multiple files. By default, that auto-grow all files is enabled on TempDB. See how big it normally runs and see if that's its initial size also. Take a look at Query Store. See if you have it enabled. If you don't, look into enabling it because it does add a lot of information, and Microsoft does enable it by default with any new databases starting in 2022. Try out SB who is active. If you haven't used it, see if you find it as helpful as I do. Dig into your queries to see if you can find your top users, or not top users, but your queries that are using the most CPU or memory or TempDB or those sorts of things, are ones that are running the longest. Not necessarily trying to find a problem, but to get used to using the tools and looking at the different metrics. So when you do have a problem, you're able to get in there and find it much faster. Take a look at your weights. They're a great way to figure out what is the slow part of your overall server. You could also look at it in individual queries if you're curious, if you have one particularly in mind that you're wondering about what's going on with performance. Then look at blocking and see if you have any long-term blocking, what might be causing that. And with that, if there's other questions, we can go through those. I'll put my contact information up here. So if you have further questions down the road, or if you want a copy of the slide deck or the queries, reach out. I'd be happy to share it with you.